lies between 90 degrees and 270 degrees, determine the value of cos theta, tan squared theta. Now, on Tuesday's lesson, ma'am taught you the cast diagram. She explained to you how it works, where to see which trig identity is positive or negative, right? So you're going to apply that to these questions. This is how they're going to ask it. They're not going to ask you a question like how you did in the exercise on Tuesday. They're going to ask it to you in this way here. Okay, so if it says sin theta equals 3 over 5, now the identity of sin, what is it? Is it opposite over hypotenuse, adjacent? How would you describe it? Opposite over hypotenuse. So that's my opposite, and that is my hypotenuse. But when you look at the 3 and the 5, are they positive or negative? Positive. They both are positive. So that already tells me sin is positive. So in which quadrants are sin positive? Second. The first and the second. Yeah. Right, so now we're going to see in which of those. It says it lies between 90 and 270. This is 90. This is between 0 and 90. 90 and 270 is these two. Do you agree? Mm-hmm. Okay. And where is sin positive between these two?
Second.
Second quadrant. Okay. So that's what your first step is, to check if it is positive or negative and which quadrant. So we saw that it's positive, sin is positive, and it lies in the second quadrant. Your next step is to draw the Cartesian plane. So you just draw this part of the Cartesian plane where sin is positive. So you have it like this with a triangle inside. And now they told us sin theta is 3 over 5. That means my opposite is 3 and my hypotenuse is 5. This is my hypotenuse, so it's 5. Opposite to my angle is 3. Okay, we have a missing value. What value are we missing? The x. Right? Yes, the adjacent, the x offers here. How would you, when you look at this, what kind of a triangle is this? Right triangle. So to find a missing value of a right triangle, you use Pythagoras, right? Pythagoras says r squared equals x squared plus y squared. Our r is 5, x we don't know, and y is 3 squared. So this is 25, this is 9. If I take the 9 over, what does it become? 16. It becomes 16. So my x is equal to, now remember, because we're getting rid of the square, we are square rooting. But when you put a square root, your answer is either plus or minus 4. The reason why we say plus or minus, when you look at this Cartesian plane, is your x value positive or negative?
Negative.
So that's how we know this is going to be minus 4. Now we have our opposite, we have our adjacent, and we have our hypotenuse. We have all three values that you need for a sin or a cos or a tan. So we've drawn our Cartesian plane, we've used Pythagoras. Now we do the last step, that is to solve the given problem. The given problem was determine the value of cos theta and tan squared theta. Hypotenuse and opposite. Yes, A over H. So cos is A over H. Remember, these two are being multiplied with each other. And tan, what is tan? Over A. But they told us this tan is being squared. Now it's just a matter of substituting. If it makes it easier for you, you can define it here. Say my opposite was 3, my adjacent we found it to be negative 4, and my hypotenuse is 5. So now you just have to substitute. What goes in place of A? Negative 4. What goes in place of H? 5. This side, what goes in place of O? And A? Negative 4. But I have to square it. Okay. This bracket stays as is for now. If I square this bracket, 3 squared is 9. And negative 4 squared 16 becomes positive 16. If I'm multiplying, I can simplify, right? No, I don't need to turpentine. Okay. I'm simplifying across. 4 goes into 4 once. 4 goes into 16? 4 times. Can I simplify this way? No. So negative 1, remember there's a negative. Negative 1 times 9? 9. 5 times 4? And then we solve it. Okay.